everyone, welcome back to Let's Unbound. We are kicking off a brand new playlist designed especially for AP Precalculus students. This series is all about mastering AP Precalculus one topic at a time. Each video will start with quick concept review, then move into three-tier problem solving from basic to advanced. And I will even throw in a bonus challenge question at the end. So we are diving into Unit 2 today in this series, and we are in episode 1. So make sure you save this playlist and hit subscribe so you never miss when a new episode comes up. Right, so let's jump straight into our very first topic, change in arithmetic and geometric sequences. Okay, so what is a sequence? Sequence is an ordered list of numbers and they will follow a specific rule or pattern. One simple example is odd numbers, even numbers. So you know how to predict the future terms, right? Because they follow a specific rule or a pattern. And each number in the sequence, we won't call it number again, we will say terms, right? Now, coming to change in arithmetic and geometric sequence. What is arithmetic? Arithmetic sequence means the terms will get changing by a common difference, okay? And geometric sequence, yes, there will be a change, but not in a common difference, but there will be a common ratio. Right, so this is the change in arithmetic sequence. Common difference will be like you will subtract and find it. Here you will divide and find it. Okay, take two terms and subtract it, you will get it. So this is by subtraction. So common difference. This change will be defined by division. Right, now there is two important sequence based on number of terms. One is finite sequence that will be having a limited number of terms like 100,000, 10,000, something like that. So it has a starting point and also an ending term. Infinite sequence means, yeah, it will be going infinitely. So there is no end for the sequence. Next one, arithmetic sequence in deeper way. Arithmetic sequence, we have seen that the change will be a common difference. Okay, so arithmetic sequence is sequence where difference between consecutive terms is a constant. You pick any two consecutive terms and find the difference. It will be same throughout the sequence. That is arithmetic. To find any term on your sequence, that is arithmetic sequence, you can use the formula AN, generally any term. If you want 100, it's A100. It's A1. A1 means first term and D means common difference. N is question of the term. If you're looking for 50th term, your N is 50. And AN is nth term. Right? So next one is geometric sequence. Yes, it's a sequence of number where each term alter the first by multiplying the previous term by a constant. So actually, this is, you take any consecutive two terms and find the ratio of them. It will be same throughout. That is common ratio. For example, 5, 10, 20, 40. It's a geometric. How? Like if I take these two terms and make a ratio 10 by 5, like this to this I'm making, then let me take this one, 40 by 20. Anyways, the common ratios be 2 throughout. It's a geometric sequence. Right, and this is general formula. Nth term of a geometric sequence is first term. A1 means first term into common ratio, whole raised to the power n minus 1. If you're working for the 100th power, here in R, exponent of R should be 99, 1 less than that. Okay, as usual, An is nth term, A1 is first term, R is a common ratio that you can find by making a ratio of taking two terms, the successor term divided by the predecessor. Okay, don't do 5 by 10. Okay, from this to this, right to left. Right, so this is the crisp review. Now, geometric sequences. Okay, let's see all sequences together. Type of change. If you see a common difference among these terms, it's arithmetic. If you see constant ratio among them, it's geometric. This is the formula for arithmetic sequence, like to find any term. This is for any term formula for geometric sequence. These are examples. Okay, arithmetic sequence will represent a growth which is linear because it's constant change, right? It will represent kind of a line. And geometric sequence will get multiplied. So there will be a sudden change over there. So that will be exponential growth. Okay. Now let's get into question number 1. Which of the following equations could represent the sequence 15, 7, minus 1, minus 9? First, let's see what kind of sequence is it, arithmetic or geometric. If you subtract 8 from this, or let's do common difference. Common difference always right to left. 7 minus 15 is 8. Minus 1 minus 7 is 7 minus 15 is minus 8. Minus 1 is minus 8. And if you subtract this, this is also minus 8. So it's an AP. Now, how to find general term? This is the formula. An equal to a plus n minus 1b. So what is my a first term? What is your common difference? This difference. N we don't know. So n is n only because the options are based on n. And d is minus 8. Let's solve this. 15. If you see anything like over there, you can use. So 15 minus 8 into n minus 1. Yes, I can see it here. 15 minus 8 minus 1. So this option looks good. Next, let's simplify 15 minus 8n plus 8. If you see anything, you can pick. I can see 15 minus 8n plus 8 is not the 6. So it's not this. 15n minus this is also not. So I will get 15 and 8 is 23 minus 8n. Yes, this is okay. And any other things will not work out because we are very sure it's minus 8n. Here it's plus 8n, so this will not be. And okay, here you can expand this and check minus 1, minus 8n plus 2. And this will give you minus 8n plus 1. But we want minus 8n, 23. So this is also not. So it's only 1 and 4. That's simple. So you should know the manipulative technique here. That's it. Here, question number 2. Which of the following equations could represent the sequence? This sequence is kind of not an AP because if you subtract 9 minus 3, 6, 27 minus 9, I think it's 18. So no, right? So let's see. Then you will start dividing and checking 9 by 3, 27 by 9, 81 by 27, 3, 3, 3. So common ratio, same 3. Common ratio, same is geometric sequence. So geometric. Then what is nth term formula for geometric? An is a1 into r power n minus 1. So what is your a1? First term is 3. So 3. R is also 3. 3 power n minus 1. So 3 power 1 into 3 power n minus 1 is 3 power 1 plus n minus 1, which is 3 power n. Right? So 3 power n is this final simplified form, but we need to pick everything over here. So let's see. Well, the first one will give you 3 power n when you simplify finally. 3 into 1 by 3 whole power n minus 1 means you reciprocate 1 by 3 will get 3 and n minus 1 will go 1 minus n. So it's not. It won't give you 3 power n. This one, yes. Because if you simplify this, 3 into 3 power n minus 1 is 3 power 1 plus n minus 1. This will get cancelled 3 power n. So yes, this matches. And this one, 9 can be written as 3 square, 3 power n minus 2. This when you simplify will get the same 3 power n. So 3 also works good. 1 by 3 into 3 power n, no. 3 power n, of course, there is one extra, so this will not be. 27 into 3 power n minus 3, 27 is 3 power 3 and 3 power n minus 3. When you add them, you will get 3 power n. The 3 minus 3 will get cancelled, so this is. And this will not be because of 3 power n plus 1. So it's 2, 3, and 5. These could represent, these equations will represent the sequence here. Right. And moving to the third question of this. How many two-digit positive integers are divisible by 4 or 9? Yes, this is based, this is an arithmetic sequence based question. So first let's find two-digit numbers divisible by 4. Two-digit numbers. How will you find it? So you have to think about what is the first number divisible by 4. The two-digit number. 10 is a two-digit number, but it's not divisible by 4. So ignore. 11 is a two-digit number, but it's not divisible by 4. 12, yes. So that's your first number. And to find next number, you just add 4. 12 plus 4, 16. 16 plus 4, 20. Like that, it should go on and it should stop at one-digit number. What is the two-digit number? What is the last two-digit number? 99. To find the last number divisible by 4, you take the last two-digit number and divide by 4. 4 2s are 8, 1 9, 4 4s are 16, 3. So from your 99, you should subtract 3. 99 minus 3 is 96. So that is your last two-digit number. Okay. So we got it. But how many two-digit numbers? 12 to 96, how much I need to count? So if you count it by writing, it will take too much of time. So if you find this term, like which term it is it 10th term or 12th term, something we should find. So what term is, like which term is 96? It's very simple. You are going to use general term formula. An is a plus n minus 1t because it's an arithmetic sequence. Like we added 4 to generate a sequence. And an is your number 96. A means first term, n we don't know. N will tell you the question of 96, and d is 4. And that's it. You can solve. First you subtract 96 minus 12, and then you divide by 4. You will get 84 by 4, n minus 1. N minus 1 is 21, and n is 22. So 22 numbers will be divisible by 4. Okay, but we need to do divisible by 9 also. Okay, don't pick 22. Next, divisibility for 9. Let's do it in the next page. Two-digit numbers divisible by 9. So what is the first number divisible by 9? 9 is divisible by 9. But next number you add 9, which is 18. So 18 is the first two-digit number divisible by 9. Then 18 you add 9, 27, 36, and so on. It will go on. 99 is the last two-digit, and we are very sure 99 is divisible by 9. So that's it. We generate a sequence. This is also, I added 9 to generate a sequence. This is also an 18. Right? It's an AP, and now how many terms are divisible by 9? So for that, you should use 99 equal to, like I'm using this formula, an is a plus n minus 1t. You know actually what is last term, but we don't know what the position is. So 99 equal to a plus a is 18, n minus 1, d is 9. So 99 minus 18 divided by 9 equal n minus 1. 99 and 9 if you divide, 11. 18 and 9 if you divide, it's 2. So 9 equal to n minus 1, n equal to 10. So we have 10 terms which are divisible by 9. But it's not 22 plus 10, 32. Again, there is a trap. Some will be common multiple of 4 and 9, right? For example, 36. 36 is divisible by 9, also 4. So in 4 also I counted this. So the same number repeats twice. So we should remove this repetition, correct? Otherwise, our count will be wrong. So you have to take LCM then. What is LCM of? Okay, let's do here. LCM of whichever number you LCM of 9 and 4. It's 36. So for sure 36 I should remove because it will occur. Then 36 times 2, 72. 72, so 36 times 3, 108. We are out of the list. So these two numbers to be removed. Okay, two numbers to be removed. Not from both the list. So total and minus 2 you should do. So the answer would be 22 we found it for 4 divisible by 4, 10 for this, and subtract 2. So 32 minus 2 is 30. And hence the answer is 30. 30 numbers will be divisible by 4 or 9. Okay. So this is a basic application within math. Okay. And this is the answer. That's it. So now we are into bonus question. If a rubber ball consistently bounces back 2/3 of the height from which it's dropped, what fraction of its original height will the ball bounce after being dropped and bounced 4 times without being stopped? Okay, I can give you a clue. Try generating a GP for this. Okay, so GP means geometric progression, geometric sequence for this. You will get an idea. So do drop your answers in the comment box. And we are into the final part. Thank you for joining today and learning with us. With this, we are wrapping the video. And if you want to join Let's Advance Student Community WhatsApp group, you can scan the link, QR code, or you can click the link given in the description. So stay tuned for the next video. Until then, keep learning, keep practicing. If you have any suggestions or feedback, make sure to post it in the comment box. Thank you. Keep learning.